Hey everybody, so this is a video with just straight chain rule examples, tons and tons of examples, 8, ocho. So let me show you the 8 examples I'm going to go through, so you can pause if you want to read them over. So you can also use this video as a way to quiz yourself. I always have all of my examples written on my guided notes at divideandconquermath.com, and so just feel free to kind of use this video however you need. So I'm going to go ahead and get started. Okay, so starting with this first one. So this is pretty classic chain rule, first of all. You know it's going to be chain rule because you would not multiply this crazy thing together 8 times, right? So there's got to be a better way. That would be using the chain rule. And if you've watched my other video where I really talk about the setup of the chain rule is all about understanding which functions are being composed with one another. So in this case, this thing to the 8th, this is my outermost function, and then this part here, this is my innermost function. So you always want to determine kind of what is the order of the composition of functions before you start. And then after that, so now what we're going to do is, I always like to work from the outside and work my way in. So I take the derivative of the outermost function. So this is something, so forget what's on the inside, just think about, you can think about the outer function as like, what would you do if this were x to the 8th? Well, you would bring the 8 down, so I'm going to bring the 8 down, and then I would subtract 1 from the exponent like this, right? So that's how you kind of get the party started, and then you leave the inner function intact like this, and now you multiply by the derivative of the inside function here. So if I take the derivative of this inner function, this becomes x squared minus 14x. And so there you go. That is really the whole thing. So then it's kind of up to you as to how you're going to simplify this. This one, I don't think you can really do too much to simplify. I would maybe write it like this. Like this. So that's 8, and then x squared minus 14x, and then this is 1/3 x to the third minus 7x squared plus 1. There's more than one way. I mean, you could always factor out an x, or, oops, sorry, and this should have a 7th here, sorry. There's more than one way that you can kind of simplify this, but this will work for our purposes. But you might find that like a book wants to see it in a different way, so then you might have to manipulate a little bit farther, so results can vary. Okay, now this one is interesting because this is going to require the product rule first, and then we use the chain rule while we're taking the product rule. So for the product rule, here's my first function. We'll say that this is my f of x and that this is my g of x, okay? So I'm assuming that you're already familiar with the product rule if you are watching this video. So first I take the derivative of the first function. So the derivative of that function is going to be just 4, right? So the derivative of 4x plus 1 is 4, and then I leave the other function alone. So I'm trying not to get too caught up that I have to take the chain rule yet. And then I leave the first function alone, and now here's where the chain rule is going to come in. So now I have to take the derivative of this guy. So remember, we have the derivative for e to the x. We don't have a derivative for e to the 3x plus 1. So this is kind of what's telling me that I have to use a chain rule. The outermost function is the e, and then the innermost function is this 3x plus 1. So taking the derivative of the outermost function, this e, so the derivative of just e to the x would just be e to the x. So that's what I'm going to write down here, just e, and then I leave the inside part intact. So there's the derivative of the outside. Now I multiply it by the derivative of the inside, so this is going to be times 3. So the derivative of 3x plus 1 is just 3. Okay, and so now we're good to go here. So really just a matter again of trying to figure out how you might want to simplify this. So I'll call this 4e to the 3x plus 1 plus 3 times 4x plus 1 times e to the 3x plus 1. There's no like best way to necessarily simplify this one, so there's more than one way to do it. Again, you could always factor out the e to the 3x plus 1. We'll just leave it like this for here. Okay. All right, so now this next one, so this one has a composition of a whole bunch of functions. So I always like to start from the outside and work my way in. So I've got cosine of tangent of e to the sine of 4x. Whole bunch of stuff going on here. So the outermost function is this cosine, and then the next function in is tangent, and then you've got e, and then you've got the sine, and then you've got the 4x. So you have to keep all of these straight. So I really like color coding when I'm first getting used to this because it just kind of helps my brain to figure out where I need to take all those derivatives. It's really common for somebody to get to like this sine of 4x and forget that they have to use the chain rule here. So try using like a color coding system if you're struggling with it. Okay, so I'm going to kind of color code as I go along here. So we start from the outside and we work our way in. So just thinking about the derivative of cosine. So just think about this. Don't worry about all the stuff going on in here. The derivative of cosine is negative sine, and then you leave all the other stuff intact. There's the first one. Okay, now we multiply that by the derivative of the next one in, which was tangent. The derivative of tangent is secant squared, so I write down secant squared, and then I leave everything else on the inside intact like this. Okay, so now we're going to continue to move our way in. So the next one in was e. So e to the x, the derivative of e is just e, right? So I'm just going to write e, and I leave the inside intact. Okay, so that takes care of that derivative. Moving on to the next one. The derivative of sine is cosine. Are you having fun yet? And then finally, last one, the derivative of 4x is 4. So if you're having trouble kind of figuring out how to break this down, if you haven't watched my rule on the chain, or my lecture on the chain rule, I really try to break all of this down. So if you're struggling with this, highly recommend you go back and check that one out. Okay, so now if I want to just simplify all of this, let's see, this will be negative 4 sine of the tangent of e to the sine 4x. Let's see, how much of this can I put together? Times secant squared e to the sine of 4x, and then times e to the sine of 4x times cosine of 4x. So basically all I did was bring this 4 out to the front, otherwise it kind of just all looks the same. So sometimes you're going to get these really crazy looking derivatives as you're practicing the chain rule. Pretty common just as you're getting practice here, so don't be surprised. Okay, now for this one's very interesting because we have chain rule and within chain rule kind of coming up in surprising ways. So let's start with the first function that I see here. So I've got sine as the outer function. This thing in here is the innermost function, and we're actually going to end up having to use the chain rule again in here, but let's not worry about that yet. So let's just start by taking the derivative. So the derivative of sine is cosine, and then I leave the inside intact. And now I have to multiply that by the derivative of this entire thing. But the issue here now is that I'm going to have to use the quotient rule. So using the quotient rule, first I take the derivative of the top and multiply it by the bottom. So let's see, I'm going to put a big square bracket here like this. So the derivative of the top is just going to be 1, and then I multiply that by the bottom function, and then I subtract that, let's see, from, so I leave the top intact, and now I have to take the derivative of this bottom function. So let's zero in on the square root of x plus 2. This is really x plus 2 to the 1/2, right? That's what this is. And this also requires the chain rule. So in looking at this, so my outermost function in this case, let's see, I'll use the blue color here. My outermost function is this thing to the 1/2, and then I'll use I'm running out of colors here, this white color for the derivative of the inside. So now, as I take the derivative of this, I have to use the chain rule again. So I'm going to bring down the 1/2, I leave the inside intact, and I subtract 1 from the exponent. And then I multiply that by the derivative of the inside. The derivative of x plus 2 is just 1. Okay, so a lot of stuff going on here. Still not done. This is just the derivative of the entire top part, right? And then I take all of this, and I take the square root of x plus 2, and I square it. So let's see, I'm actually going to change this green bracket here. Whew. Okay, so lots of stuff going on here. So from this point forward, you can make some simplifications. So if I were to try to simplify this, there's a lot of different ways to kind of do this particular one. So let's see. Actually, I think I'm going to make a little room for myself. Okay, so I've got it so that I can maybe visualize this just a little bit better. Okay, so I'm going to have that y prime is equal to the cosine of x over the square root of x plus 2. And now let's work on just simplifying the square bracket part. So let's see. This is going to be the square root of x plus 2 minus, let's see, this will be, let's break this up into two pieces actually. So this first piece, I'll just take this over this. So this will be the square root of x plus 2 over, so this squared will make this just x plus 2. So there's the first part. Now I'll subtract off the second part. So as I look through this, so this will actually become 1x on top, so we'll just maybe write that as just x over x plus 2 times the square root of x plus 2. So here's how I could kind of simplify that, and then I could take this, looks like a step farther with a couple of these. So this is y prime equals cosine of x over the square root of x plus 2. And then this will simplify to 1 over the square root of x plus 2. And then this will be minus x over, let's call this x plus 2 to the 3/2. So that's one way that you could simplify this. Now sometimes people say, well, can't I also multiply this x over square root of x plus 2? Can't I multiply this into this? You cannot, right? This is part of cosine. So because this is part of your cosine function, you can't just easily break this up or try to distribute it. So make sure you don't fall into that particular error. Sometimes our eyes play tricks on us. Okay. So moving on to this next one. So this is a little bit crazy. So in this one, we kind of have a mega product rule, and then we have chain rule within chain rule. So let's first just note the three functions here. I've got x to the third, e to the negative 2x, and sine of 5x. So basically what I'm going to do is I'm going to go through and take the derivative of each part, and then I leave the rest of the function alone. So let's just jump right into it. Okay, so we'll start with this first function, x cubed. So taking the derivative of x cubed is 3x squared, and the rest of this we just leave alone. So we don't do anything to the rest of this. Okay, so that's the derivative of the first one. So now I'm going to leave x cubed alone, and now I'm going to make my way over to working on this function here. Okay, so now you can see if I take the derivative of this, I'm going to have to use a chain rule. Here's the outermost function, here's the innermost function. So taking the derivative of the outermost function, that will just be e. I leave the inside intact, and then I multiply that by the derivative of the inside function, which is just negative 2. So here's that part, there's the derivative of this, and then don't forget, you still have to multiply by the last part of this. So still times sine of 5x. Whew. Okay, so now I leave the first function alone. See, I'll write this as e to the negative 2x. I leave the second function alone, and now I have to take the derivative of this guy. The derivative of this guy, once again, requires a chain rule. The outermost function is sine. The innermost function is 5x. So the derivative of sine is cosine, and I leave the inside intact. And then I multiply that by the derivative of the inside function, which is just 5. And so now we've got all the pieces of our derivative. And so now from here it's just a thing of simplifying, really. So this will be 3x squared e to the negative 2x sine of 5x minus 2x cubed e to the negative 2x sine of 5x, and then finally 5x x cubed e to the negative 2x. Let's see, I'm running out of room here, but cosine of 5x. Okay, and you could, once again, you could factor some things out if you wanted to. Looks like you could factor out at least x squared and e to the negative 2x. I'm just going to leave it at this, but you could always, there's other ways you could write this. Okay, so moving on to f here. So once again, so this is actually requiring the product rule, and then the chain rule is just going to pop up. So here's one function, here's the other function. So let's go ahead and get this party started. So first I'm going to take the derivative of 5x. The derivative of 5x is just 5, and then I leave the second part of this alone. Okay, so now I leave the 5x alone, and now I have to take the derivative of this piece, and now this is where the chain rule comes in. So outermost function is going to be this thing to the 5th. The innermost function is this part here. So I'm going to multiply this. I'm going to bring the 5 down. This is e to the negative x minus 4x plus 2, and then I subtract 1 from it. And then what do? I multiply by the derivative of the inside function. So now, when you take the derivative of this piece here, this requires the chain rule again. So e to the negative x. So e to the negative x. Remember, we have the derivative for e to the x, not e to the negative x. So in this particular little piece here, this is the outermost function, this is the innermost function. So now, as I work to multiply by the derivative of the inside, first I have to take the derivative of e to the negative x. This will be e to the negative x times negative 1. Derivative of the outside function times the derivative of the inside function. Okay, and then I take the derivative of negative 4x, which is just negative 4. Okay, so now I've got all the pieces here. And then it's just, once again, that game of cleaning everything up. Oops, and sorry, this was supposed to... nope, no mistakes. Okay, sorry. I thought maybe I made an error. Okay, so there's the first part. And then here's the second part. 25x times e to the negative x minus 4x plus 2, all of that to the 4th, times negative e to the negative x minus 4. Not the prettiest looking derivative, but it is what it is. Okay, so now moving on to this next one. So now we have, once again, the chain rule within the chain rule. So let's just worry about the outermost function here. So here's the outermost function, here's the innermost function, and we'll kind of work through this as we go along. So first I want to take the derivative of the outside function. So what I'm going to do is I'm going to bring down the negative 3. I leave all the stuff that's inside, I leave it all intact. Don't touch it. And then I subtract 1 from the exponent here. There's the derivative of my outside function. Now, I'm going to multiply this by the derivative of the inside. Now, as I think about taking the derivative of the inside, I'm going to have to use the quotient rule. So the quotient rule requires that first I'll take the derivative of this top function and multiply it by the bottom. So if I take the derivative of the top function, so let's see, this is going to be big derivative again. This will be 1/2 x to the negative 1/2. So there's the derivative of the top, and then I just multiply that by the bottom, so I don't do anything to the bottom right now. E to the sine x. Okay, so now I leave the top part intact, square root of x plus 7. And now I take the derivative of e to the sine x, and we have another chain rule in here. So if I just want to blow this out for a second, I've got e to the sine x. The outermost function is e. The innermost function is sine of x. So this is going to be e to the sine x, and then I multiply that by the inside function, and that's cosine x, or the derivative of the inside function. There's all the pieces, and then I divide all of this by e to the sine of x, and then I square it. And from here, so you'll basically just kind of clean it up from here. So it looks like we can actually cancel out one of these e to the sine x's. So I will go ahead and do that. So let me make some space. And so this guy will equal -3 times the square root of x plus 7 over e to the sine x, all of that to the -4th. Now, as you look across this whole thing, you can see that you can cancel out 1 e to the sine x in all of these. So I'm going to cancel out this one, and I'm going to cancel this. So now I'm just left with 1 e to the sine x. Okay, so now what this is going to read, if I want to write this in two separate fractions, this would be 1 over 2 times the square root of x e to the sine x. So that's taking this part here over this part here. Now I'm going to subtract, and this will be the square root of x plus 7 times cosine of x, all of that over e to the sine x. Sorry, I'm getting a little squished here. But there's one way that you could simplify this. Again, there's more than one way to do it, so I'm just showing you one way. Okay, and now, last but not least, we have another gnarly chain rule problem. So there's actually chain rule within chain rule here. So as I'm looking at this is going to require that I use the quotient rule. So let's just go ahead and get it started. So to use the quotient rule, I take the derivative of the top. And now as you look at the top, you'll notice that you have to use the chain rule to take that derivative. Here's the outermost function, there's the next one in, and there's the last one. So let's go ahead and take this derivative. So this will be, the derivative of e is just e, so this is e to the sine of 4x. Okay? Now I multiply that by the derivative of the next function in, so the derivative of sine is cosine. So the derivative of sine is cosine, and then I leave the inside intact. And then I finally multiply this by the derivative of the innermost function, which is just 4. So remember, we're using the quotient rule here, so I take the derivative of this, and then I just multiply it by this other function. So I haven't done anything to the other function. So this is going to be all of this times x squared cosine of 3x minus 1. There's the first part. Now I'm going to subtract this function, e to the sine of 4x, and then I'm going to multiply that by the derivative of this whole thing. Now the derivative of this guy is going to be real gnarly because we've got to use the product rule and a chain rule. So in using the product rule, so what are the two functions here? So here's one function, here's the second function. So there's what I'm going to use my product rule on. Now, at first, to use the product rule, I take the derivative of this one, so x squared. The derivative of x squared, let's see, I'll even put square brackets around this. The derivative of x squared is 2x, and then I just multiply that by the other function. Okay, and then I add to this, I leave x squared alone, and now I have to take the derivative of cosine of 3x minus 1. And now, within the cosine 3x minus 1, I have to use the chain rule. And in this one, cosine is the outermost function, and 3x minus 1 is the innermost function. So the derivative of cosine is negative sine, and then I leave the inside intact. And then I multiply all of that by the derivative of the inside, which is just the 3. Okay, and then let's see, I've got all of this was multiplied ultimately by this part. And now remember, all of this that we just did, this is just the top part of my derivative. So let's see, I'll actually put some nice big golden brackets around this, so it starts here and it ends here. And then all of this is divided by the denominator squared. So this divided by x squared cosine of 3x minus 1, and then all of that squared. Okay, so let me know if you wish that I had actually simplified this all the way. I think I've got all the pieces here, and from here you can kind of mess around with this and finish this. I'm going to leave this here because this video is already getting long, but just leave me a comment if you wish I would have finished this, because I can always make an update to this video. So that's what I've got for you guys in this video. If you have questions or comments, feel free to drop me a line below in this video. I'm always looking for suggestions. Thanks for watching, guys. I'll see you next time.